This video is on Unit 2, Chapter 5, Solving Quadratic Functions, Lesson number 2, Solving Quadratics Using the Quadratic Formula. In your notes here, it gives you the quadratic formula on the very left. It says x equals opposite b plus or minus the square root of b squared minus 4ac. All of that is going to be divided by 2a. So the quadratic formula is one of the many methods that we're going to look at on how to solve a quadratic function. Lesson number 1, we talked about solving by graphing. In this lesson, again, we're solving using a formula. You need to learn the formula. You need to have it memorized. We'll talk more about that in class. But you need to memorize the quadratic formula. Steps here are going to tell you to write the equation in standard form. Standard form for a quadratic is ax squared plus bx plus c is equal to 0. Please keep in mind that if you have the 0 on the left, that's okay too. So it may say 0 is equal to ax squared plus bx plus c. Second step is going to be to identify the a, which is always the coefficient of the x squared, the b, which is always the coefficient on the x, and then the c, which is your constant, that plain number that doesn't have an x. We're going to substitute the a, the b, and the c into the formula, and then third step says to simplify. Now, there's something I want to add to these notes. You need to add this as well, somewhere in the margins of your guided notes page. Keep in mind here that, again, this is your quadratic formula. X equals opposite b plus or minus square root of b squared minus 4ac divided by 2a. And that's from the standard form of quadratic, ax squared plus bx plus c. And again, you're identifying the a, the b, and the c, and we're going to plug that in. The definition or the terminology, the vocabulary I want to talk to you about is called the discriminant. The discriminant is the b squared minus 4ac part of the quadratic formula. So it's only the part that's under the radical. It's not including the radical, just the stuff that's underneath it. What we're going to do is as we work these examples, we're going to talk about the discriminant, and we're going to look at and try to decide what kinds of solutions we're going to have based on the discriminant, because that's what the discriminant does. The discriminant tells us how many and what kind of solutions we're going to have. If the discriminant is positive, so see my plus here. If the discriminant is positive, two different things can happen depending on whether it is a perfect square or a non-perfect square. If it's a perfect square and it's positive, you will have two real rational roots. So they'll be what I call somewhat pretty. They might be fractions, they might be whole numbers, but they're going to be rational. If it's a non-perfect square, then we know we're going to have two real irrational roots, which means that we are going to have radicals in our answer because they're irrational. If the discriminant comes out to be negative, then we know we are going to have two complex roots. That's that a plus bi. And then if the discriminant is equal to 0, we are only going to have one real rational solution. Again, that means it could be a fraction, it could be a whole number. We just don't know what that could look like. But this goes right along with the notes that we took for lesson number 1. If your parabola hits the x-axis 2 times, you're going to have two solutions. Those two solutions can either be, and that happens when the discriminant is positive. We know we have either two rational or two irrational. And this goes with the positive. If we have two complex roots, that was where the parabola never came down and hit the x-axis at all. 0 real rational, or 1 real rational root was where the parabola hit the x-axis just one time. So this goes right along with what we learned in lesson number 1. All right, so let's look at some examples. The directions tell you to solve each quadratic equation below using the quadratic formula. So I'm going to look at example number 1. Notice here that we have 1x squared plus 2x minus 63 is equal to 0. It is already in standard form. A is equal to 1 because that's the number that's in front of the x squared term. B is equal to 2 because that's the number that's in front of the x. And then the C is equal to a negative 63. So the next step is to take your quadratic formula and substitute those numbers in. X equals, y'all, we are solving for x. X can either be 2 numbers or 1 number. It might be too complex, it might be too rational, it might be too irrational, or it might be 1 rational. We are solving for x. What does x equal? The formula is going to help us. So the little negative b that's out front, I like to say opposite b because whatever the b is, which in this case is a 2, I'm going to make it the opposite. That's going to be a negative 2. The plus and the minus that's part of the formula gives us the 2 solutions in the end, which I'll explain that here in just a second. So then we're going to substitute in the b, which is a 2. So that's b squared minus 4 times a is 1 times c is negative 63, all divided by 2 times a is 1. Now, I want to focus on just the discriminant, just the 2 squared minus 4 times 1 times negative 63. That's the only part I'm going to put in the calculator right now. I'm going to put in the parentheses 2 squared minus 4 times 1 times negative 63. My discriminant is 256. The discriminant is 256. And I'm just going to put capital D equals 256. So it's positive. Go back to your notes here. The discriminant here is positive. Now, is it a perfect square or is that a non-perfect square? Well, let's check. What is the square root of 256? It's equal to 16. So what that tells me is I'm going to have some nice, pretty answers. These are going to be rational. It is a perfect square. I'm going to have 2 real rational roots. So let's go back to our example. X equals negative 2 plus or minus the square root of 256 all divided by 2. Now, the square root of 256 we already said was 16. So negative 2 plus or minus 16 divided by 2. Now, that is not our answer. We don't have our answers yet. What we need to do to find those answers is split this up into the 2. So the plus and the minus that's right here is going to give you your 2. Negative 2 plus 16, you're going to divide that by 2. You're going to take negative 2 minus 16 and divide by 2. And that will give us our 2 solutions. So I'm going to go to my calculator. I would prefer that you use the alpha y equal and bring up a fraction so that your order of operations are actually correct. So negative 2 plus 16 divided by 2 gives me a 7. So 7 is one of my answers. And then do the minus. Same thing. Negative 2 minus the 16 divided by the 2. And we get negative 9. So those are the 2 solutions for number 1. Let's jump down to number 3. Looking at number 3, it says negative x squared plus 2x equals 1. So this one's not in the correct order. Remember, it has to have an equal 0. So we're going to subtract the 1 from both sides to get the 0 on the other. Now that I've done that, I can identify the A. A is -1, B is a +2, and C is -1. All right, so let's go from there. Back to your quadratic formula. X equals opposite B plus or minus the square root of B squared minus 4 times A times C all over 2 times A. And again, before I do anything else, I'm going to focus strictly on the discriminant. So look at the stuff that's underneath the radical. 2 squared minus 4 times -1 times -1. And I haven't said it yet, but parentheses are your friend here. 2 squared minus 4 times -1 times -1. And we get 0. So the discriminant here is 0. Two times -1 is -2. So let's think about that for just a second. What did I tell you about if the discriminant is 0? Well, if the discriminant is 0, I have one real rational solution. There's just one. And here's why. If you're looking at this, the square root of 0 is just 0. If I add 0, I get the same answer. If I subtract 0, I still get the same answer. So this plus minus part just basically goes away, and we end up with -2 divided by -2, which is a +1. So the solution to number 3 is just 1. All right, let's jump to number 7. We're going to look at number 7. X squared minus 9 equals 4x. So again, there's not a 0 here. I need to make this standard form. We're going to subtract the 4x. Order is going to matter. The x squared term comes first, then the minus 4x, and then the minus 9. A is equal to 1. B is equal to a -4, and C is equal to -9. So again, we're going to take the A, the B, and the C. We're going to plug it into the quadratic formula. The quadratic formula says X equals opposite B. Now, B is a -4 here, so the opposite of that is a +4 plus or minus the square root of B squared minus 4 times A times C, all divided by 2 times A. And that's what that looks like. And a minute ago, I said parentheses are your friends here, and I'm serious. I put that -4 in parentheses for a reason, so that we can make sure we get the correct answer here. So going to the graphing calculator, again, I'm only going to concentrate on the discriminant. So -4 squared minus 4 times 1 times -9. And then enter. My discriminant is 52. Now it's positive, so I know I have 2 real solutions. It's positive. I know I've got 2 real. 52. Two times 1 is 2. Go back to your notes, though. What happens if it's non-perfect? Now, I'm telling you right now, it's not perfect. 52 is not a perfect square. If you don't know that, try to take the square root of it. It gives you a nice long decimal. That's irrational. That is an irrational number. So it is a non-perfect square. I have 2 real irrational roots, which again means you're going to have radicals in your answer. So what am I going to do with that? Your answer is not okay in this form. we got to figure out how to simplify the square root of 52. This is going to go back to chapter 4. How do I simplify a radical? We're going to go to the y equal. We're going to put the 52 divided by x squared. Look at your table. And it's going to be 2 times the square root of 13. So this is where it crosses over to 0. Go up to the first perfect number, the first whole number. 2 times the square root of 13 is how I rewrite that. So 4 plus or minus 2 times the square root of 13 all over 2. Now you would think we would be done, but we are not. We are not done. So there's a couple of numbers here. There's 4 and the 2 and the 2. All three of those have to have a common factor in order to reduce. These three terms, these three numbers here that I've highlighted with that little green dot, all have a common factor of 2. So we've got to reduce. But it's only when all three have a common factor. So what is 4 divided by 2? 2. Plus or minus 2 divided by 2 is 1 square root of 13. Now that 1 is not necessary. And then 2 divided by 2 is still 1. Now, a couple of things are not necessary here. The 1 in front of the radical is not necessary. I'm going to erase that. The 1 in the denominator is not necessary, which means my fraction bar is not necessary. So my answer for number 7 is 2 plus or minus the square root of 13. Now I need to jump down to number 11. Number 11 says negative 3x squared plus 8x minus 7 is equal to 0. This one's already in standard form. A is equal to negative 3, B is equal to 8, and C is equal to negative 7. So plugging this into our quadratic formula, x equals opposite b. B is 8, so that's going to make that a negative 8 plus or minus the square root. B is 8 squared minus 4 times A times C divided by 2 times A. All right, so x equals negative 8 plus or minus, I got to use my calculator to find that number that's underneath the radical. 2 times negative 3 in the denominator is a negative 6. All right, to the calculator to find the discriminant. Again, parentheses are your friends. Use them. 8 squared minus 4 times negative 3 times negative 7. My discriminant is negative 20. Negative 20. Now, what does that tell me? Well, number 1, that tells me I have 2 complex solutions. We have 2 complex solutions, A plus BI. The other thing that tells me is that because the 20 is a non-perfect square, not only do I have an I, but I'm also going to have a radical. So, how do we simplify? I'm going to go down here to the bottom. How do I simplify the square root of negative 20? Think back to chapter 4. The negative underneath gives me an I on the outside. We need to simplify that square root of 20. Y equals 20 divided by x squared. And it's going to be 2 times the square root of 5. So 2i times the square root of 5. That's what the square root of negative 20 reduces to. So x equals negative 8 plus or minus 2i times the square root of 5 all over negative 6. Okay, so I'm gonna put a dot on the 3 spots. Do those 3 numbers have something in common? Yes, they do. They all have a 2 in common. And I'm going to go one step further and say negative 2. And the reason I'm going to say negative is because you are never allowed to leave a negative in the denominator. Always divide it out. If you can do nothing else, you're going to divide by a negative 1. but we can divide by a -2. So what is -8 divided by -2? That's a 4. Now, the 2 that I have highlighted in green, that 2 is a +2 and a -2. So when I divide that by a -2, it's not going to change the sign. It's still going to be a positive and the negative. And 2 divided by 2 is 1. We don't need the 1. I radical 5. All over -6 divided by -2 is a +3. And there's my answer for number 11. Now, what I did not explain, and I need to go back and make sure I explain this to you, is the way that answer is on number 11, that's both answers. That's 2 answers. Your answers are 4 plus I radical 5 over 3 and 4 minus I radical 5 over 3. Those are the 2 solutions for number 11. I choose not to write it that way. I choose to leave it in this form right here, which is a more condensed answer. Same thing on number 7. The 2 plus or minus the square root of 13 is 2 answers. One of them is 2 plus the square root of 13. The other one's 2 minus the square root of 13. I just choose to leave my answer in a more condensed format. All right, that's your notes on the quadratic formula. We will work in class on the assignment.